Hey guys, Mr. Blue here with another quick little video about how to calculate our number of protons, neutrons, and electrons using our atomic weight, or sometimes called our atomic mass. Okay, so last lesson we were just talking quickly about protons, neutrons, and their locations. Now the other thing to point out is that basically what we have is when we talk about weight with protons and neutrons, we give them sort of an arbitrary number. Now the arbitrary number is what we call 1. So protons have a mass of 1 AMU. AMU stands for atomic mass unit. Now neutrons also weigh 1 AMU. Now electrons, it's impossible for something to have no mass. That would defy Einstein's theory of relativity. But electrons have very, very little mass. And we usually say that they have about 0.005 AMU. So in terms of our purposes here in high school chemistry, we basically pretend that electrons weigh nothing, okay? Even though that theoretically is not true. So now you've obviously seen the periodic table before, okay? And we usually get a tile that looks something like this. So here's gold, and gold has what we call an atomic number of 79 and an atomic mass of 196.967. And what we need to do is we need to be able to use those numbers to tell us some different things about an element. You don't need to memorize the periodic table. You just need to know how to use it. So let's have a quick look at an example of what I mean by this. And let's look at lithium. Okay, element number 3, let's look at lithium. Now, lithium, all right, for our simplified purposes here, lithium, okay, has that atomic number of 3, and then it has an atomic mass here of 6.941. Now, what we usually do with that 6.941 is we can't have a rounded number. We'll talk about why they're rounded a little bit later on when we talk about radiation. But what we get here is we round that to the nearest whole number. So 6.941, we round up to 7. So what we've got here now is we've got lithium with 3 and 7. Now what we need to know next, okay, is that atomic number, okay, that atomic number tells us the amount of protons. So in this scenario here, lithium is going to have 3 protons. So let's draw them in. 1, 2, 3. Okay, nice and easy. Now the next bit is briefly at the start of this lesson, I told you that basically electrons have no mass. So therefore, okay, we can therefore assume that the other 4 articles of mass are coming from neutrons. So our neutrons here are going to be the other sections of mass. Now, are they going to be 7? No, because we've already got 3 atomic mass units of protons. So to calculate that, 7 minus 3 equals 4. So there, on average, inside of a lithium atom, there are 4 neutrons. Okay? Now, I should have drawn those the same size. That's a bit of a weakness to my model. Okay, so the next bit, right? At the moment, we've got 1, 2, 3 positive charges. Now, for lithium to be what we call an atom and have no charge next to it, all right, we call that its atomic state, that it needs to have an even number of protons and electrons in this atomic state. So what we need to do next is we work out, well, I got 3 protons because that's what my atomic number says. Therefore, I must have 3 electrons. Now here is where we go with our shells, and you'll see the shells around the outside here, okay? Now shells are a really easy way to demonstrate electrons, and we'll talk about evidence for how these shells exist a little bit later on. So let's draw our shells in here. So our first shell has just a capacity of 2, but we've got 3 electrons, okay? We've got 3 electrons there. So what I do is I put my first 2 in. So my first shell has a capacity of 2. My second shell has a capacity of 8, and my third shell has a capacity of 8. That's about as far as we'll probably go for the first part there, so we can stop there. So our next part is we need to draw another shell here. Now, these ones on the inside, okay, are going to stay inside of that shell, and then we have another and our third one on the outside shell. Okay, and that is how we do our various setups there of protons, neutrons, and electrons. Let's briefly look at another example, shall we? Okay, let's briefly look at another example. Let's go back to our periodic table quickly, and let's have a look at another element. Let's go with I need a better periodic table than that. I need one with two numbers. Let's do oxygen, okay? So oxygen, okay, element 8, 16, okay? Therefore, it's going to have 8 protons, and because 8 minus 16, it's going to have 8 neutrons. Now, because there's no plus or minus next to it, we assume it's in the atomic state, so therefore it's going to have 8 electrons, okay? So let's draw that. We can do 1, 2, 3, 4, 5, 6, 7, 8. Okay. Or alternatively than that, you can just go over here and write 8p, 8n, and then we draw our shells around it. So we have our innermost shell has a capacity of 2. Let's fill it up. 1, 2. And then our outer shell has a capacity of 6. We're not going to quite fill that up. 1, 2, 3, 4, 5, 6. We often draw them in pairs together like this, and I'll talk about that later on in the course and in the year. Okay, so you draw them together in pairs, and then they're spaced away as far from each other as they like to be, because, as I said earlier, the charges will repel away from each other. Okay, so there's another example there. Okay, really simple stuff, too easy. Okay, now let's look at one final example. Let's have a look at what an ion is. Okay. So let's go back to our lithium, okay, that we had at the start of the lesson. So lithium 3, 7, okay. Now what we're going to have with lithium most of the time in lithium's career is that it's going to have 3 protons, 4 neutrons in the middle, and then it's going to have 2 electrons in its inner shell and 1 in its outer shell. Now electrons don't like to exist like this. The aim of an atom, roughly, I don't like to personify them, but is to basically to live on its own. It wants to have a full outer shell. Okay, it wants to have a full outer shell. Now to do that, okay, it can either take on 7 more in its outside, or it can get rid of 1. And most of the time, in fact, all of the time, lithium is going to get rid of its electron. And this is what actually makes lithium very, very reactive, which again, we'll talk about in later videos. So it's going to fling its electron off. Now what's happened? At the start, lithium had 3 protons. Protons equals 3. Neutrons equals 4. Now, however, we went from 3 down to just 2. Okay? So what's happening now is we've got a disparity. So at the top here, I had 3 protons. So I had 3 positive charges. Remembering my protons are positive. Neutrons, who cares about them? They've got no charge whatsoever. Okay? Not relevant to us here. However, we've now got 1 negative here. Okay? Sorry, only 2 negatives left over. So what we've got now is, in terms of if we look at it like on a really simple number line, so here's 0, okay? And then we're going to have 1, 2, and 3. We started off, I guess, with 3 positive charges. And usually we'd have 3 electrons to balance that back down to 0. However, this time we've only got 2 negative charges. So we go back and we go there like this. So what we end up with is we've still got a 1 positive charge. And we write that there like that. And that is how we understand that we have ions, okay? And that is the formation of an ion. Ions that are said to be positively charged are called cations, and ones that are said to be negatively charged are said to be anions. Okay, we'll look at more examples of that later on. This is Mr. Blue with another high quality at-home video.